Hello everybody, welcome to again maths review lesson. In this lesson we will see some fractions, decimals, geometry, measurement and some statistics elements we will see and we will learn. This lesson will be so fast and so easy. So let's start from fractions. Remember what was the fractions? We were having one things and we were cutting two equal or some equal parts. For example, I am getting to 1, then it is 1 out of 2, or I can read 1 over 2. It means that I got one part from this. This is showing like that. So let's remember what was the first one, the upside. Of course, it is numerator. How I can write like that. So what about here? This is fraction bar. So what about the bottom side? It is denominator. Denominator, how I can write? So it is so fast, we have to go to the so fastly. Okay, just for example, okay, like that. For example, this there, like a pizza. So I am cutting the 4 times. Okay, so I am getting the 1, the other side I take other piece, then third piece too. How many piece I get? 1, 2, 3. From how much? 1, 2, 3, 4. Look. So what is our numerator? It is 3. So fraction bar and denominator. Okay, numerator, denominator is here. Okay, so let's come to do how we were showing on the number line number, or it's 0, then it's 1, of course. So for example, let's show that fractions on number line. So how many parts I got? 2. I have to cut 2 equal parts. Look, for example, 1, 2. It is 2 equal parts. Okay, so how many parts I got? Just 1 part. So it is here. Okay, so wall is this. What about this? Again 0, again 1, but they are going to do infinity, these number lines, of course. So how many parts I have to cut? 4. I have to make 4 pieces. That's why I have to cut 3 times. Then, okay, these equal parts. This. Okay. This is not a part, just this. 1, 2, 3, and 4. This is not okay. So how many parts I will get? 3 parts. 1, 2, 3. Okay, because these are my things. So this is the 3 out of 4. Okay, so let's be quickly. Okay, so we have to come to the fractions. If they are smaller one, bigger than, greater or something, like we will see this, because if it's the numerator is greater than denominator is different things, numerator. Okay, so we will come to, so proper fractions. What is it, proper fractions? If that numerator is smaller than denominator, then it's just a proper fraction, like basic fractions. Okay, for example, I give you 1 out of 5, or 6 out of 7, or 11 out of 13. These are the proper fractions. Okay, so like smaller than whole parts, you will understand here. Improper fractions, how, then it is the greater than the wall. Okay, for example, I cut it wall 4 times. Okay, then I am getting to all of the 4, but I don't it's not enough for me, so I want more. So let's choose another equal, but they're equal parts. 1 2 3 4. I choose. I need 2 more to, so 1 2. I got it. So how many parts I took? I got 1 2 3 4 5 6. But from what? How many? 6. From how many parts they cut? It's 4 cut. Look, from 4 pieces, like we cut at the wall, how many divided? 4 times. So how much I got? It's 6 I got. So what it means, look, wall and something more than wall, isn't it? That's why it is also is greater than 1 2 all time. That's why it's improper fractions. Okay, then let's come to do improper fractions. But how? Also I can show that 6 4. I can show how. Just remember, or just put like that. Okay, one wall, isn't it? Remember, it was one wall. Then just look at here, one wall, and how many? 2 from 4, like that. For example, 2 4. I can show also like that, this. Okay, look, some fractions can be different modes, different numbers, but they can be the same, equivalent. Then we are talking about, of course, equivalent fractions. Equivalent fractions. Okay, what is that? What I mean? For example, this is the wall. What that? It is something like pool. Okay, or how you can call? It's like a pool. I mean. So you are cutting the pool like a two side, equal side. So you are choosing here. So what is that? It is 1 out of 2. Okay. Still the same pool we are talking about, because they are equal. Okay. So, but I don't cut 2 times. I am cutting 4 times. Then look, if I cut 4 times, then if I choose 2, what did you realize? Look, that 2 is equal to that one, isn't it? So 2, if I choose 2, from how many? 1 2 3 4. If I choose like that, then this is equal to this one, so equivalent to each other. Okay, so I have to show like 3, like equivalent. Okay, so what you realize, look, this is the 1, this is 2, this is 2, this is the 4. So it's something like enlarging the numbers, equivalent numbers. Okay, so let's look at the enlarging. Okay, what I mean, for example, as you see, you can't call like 3 5. Okay, let's enlarge this fraction, but with the same numbers. On the fractions, if you do some things for here, then you must do here the same things with. Okay, for example, if you are making the multiply or division here, then denominator also must be the same operation. you have to make here the same things too. Okay, so let's do that one again. For example, I want to make multiply by 4. Then I have to make the 4 too. Then that fraction will not change. 3 times 4, it is 12. 5 times 4, it is 20. Then what it happened? Then that 12, 20 is equivalent to 3, 5. Okay, because what? Like this. You can write again. Look, 3 times 5 equivalent to 12, 20. Why? Because 4 times. So also this is 4 times. That's why it's the equivalent. Okay. So also we have how can I say you that, like simplifying. Okay, simplifying. How I can write like that? Simplifying fractions. So it's opposite of the enlarging. Enlarging making the growing. You are making grow with the same numbers. So simplifying, you are making the basic. You are coming to the back. If you are making enlarge by multiplication, then simplifying you need to make divisions. Okay. For example, 12, 20. Okay, let's make simplifying by 2. Okay, I am making division by 2, so also this is by 2 I make. So 12 divided 2, it is 6. Then 20 divided 2, it is 10. Okay, I can continue again by 2, isn't it? Because they are the even numbers, so even numbers can divisible by 2. Then this also can be by 2, so 6 division or divided 2, it is 3. Then 10 divided 2, it is 5. Look, 3, 5, 3, 5 before the first fractions, before we enlarge it. If we are simplifying, then we are going to the back. Okay, that's great then. So let's look at the adding fractions. Okay, how I can add the fractions? For example, 1 out of 3 plus 2 out of 5. How I can do? Do you think that it is like that? No, it is not like that. Okay, there's the rules. We have to look to the where denominator. We have to look to denominator. If they are the same, like, then I can do. But if they are unlike, different, then I have to change. Okay, keep here this. Okay, keep here. Then we will turn this. But let's look at the fractions. For example, 1 out of 4 plus 3 out of 4. Look, denominator are the same. If they are the same, then I can make addition. So this will be the same. Okay, keep this same. Don't change, because you are talking about, I will come right now, 1 plus 3. Just you are adding the upside, the numerator, then it is 4, 4. Then it is also 1, as you know. So what means this? Look, let's make addition with the figures, models. Look, voltings, so they cut it to 4. Okay, so they took 1. Okay, plus. So what about these fractions? How we can show as a figure? Of course, again, equal parts is important. Equal parts. Okay, these parts cannot change. How many parts I will take? 1, 2, 3. Then it is equal, again the same 1. How much? 1, 2. I'm adding 1, 2, 3, 4. 1, 2, 3, 4. Look how much I choose. 4. From what? From 4. This is the wall or not? Yes. That's why it's like that. Okay. So let's look at today if they're unlike. Unlike denominators. As what was that one? Let's look at here again. Look, 1 out of 3 and 2 out of 5. 1 out of 3 plus 2 out of 5. Okay. What it means? Oh, it's so hardly. Okay. So keep it this again. After we will come there. Okay. So just look at another question, another example. 1 out of 2 plus 2 out of 4. Look, they are different too. Okay. So what can I do? So it's hardly, isn't it? If I make enlarge by 2 this fraction, do you think that denominator can be same with the 4? Enlarging by 2? Yes, of course. So let's do. Look, 1 multiply 2, 2 multiply 2, isn't it? 2, why 2? Because it's 4. To make 2, this 2, to make 4, what I need for multiplication? I need 2, because 2 times 2 is 4. That's why I must make enlarging by 2. Okay, so 1 times 2, it is 2. 2 times 2, it's 4. Look, these are equal anymore. So I can write these fractions for this fraction. I can write this fraction for this fraction. Okay, so let's write. What is this? This is anymore. 2 out of 4 plus 2 out of 4. It is 4 out of 4 again. So it's 1. Doesn't matter. It's so different. It can change. For example, another question. For example, 3 out of 5 plus 2 out of 10. What can I do again? Look, to make this 5, to make the same denominator, what I have to do? Multiply 2, of course. Let's do 3 times 2, 5 times 2, then it is 6, 10. Okay, so this is this anymore. So I can write this like that. So plus this 2, 10. It is 8, 10. This is the fast review. Okay, you are just remember what was that. Let's come this. These are the hard things. Okay, so you have to know that I have come. So 1, 3 plus 2, 5. You must make denominator are the same. Look here, always we were enlarging just one number, isn't it? So you can enlarge or simplify, doesn't matter, to both of the fraction. Just for us, important thing that you have to make same operation with the same both side. Okay, so you can do another things, but it must be same with this, same with here too. They can be different, doesn't matter, but they must be same. Okay, for example, okay, 3, 5. Remember the last one, greatest common factor and least common multiples. Remember this one? What was that? So let's look at the LCM of 3 and 5. Okay, so multiples I have to look in which multiples, which number they are connecting, they will be same. Okay, 3, 9, sorry, 6, 9, 12, 15, it will go to 5, I am coming here, 10, 15, it will go to first, what was this? 15. So they will be the 15, they will connect. To make 15, what I need, which number I have to enlarge? With the 5. And for this, to make 15, I have to make 3. Okay, let's do 1 times 5, it is 5. 3 times 5, it is 15. Plus 3 times 2, because I am making enlarging by 3 this. 3 times 2, it is 6. 5 times 3, it is 15. Then denominator are the same. So first it was unlike, but now it's like. So 5 plus 6, 11. Okay. So it's the same things for the fractions too. If their denominator are the unlike or denominator is the same, you can do same things for the addition what we do. Okay, for example, let's look at this. 3 out of 4 minus 1 out of 2. How I can do this? Different denominators, so I have to make enlarge this by 2. Okay, 3, 4, I am writing the same. So what about here? If I make enlarge, so 1 times 2, it is 2. 2 times 2, it is 4. Look, same denominator. So now I can do 3 minus 2. They are the same. Keep this same. Denominator always same. Don't worry. Don't forget. 3 minus 2, it is 1. Did you see? It's like that. So okay, one of the last subject of the fractions. Okay, finding a fraction of a number. Finding a fractions of the number. Okay, how we can do? For example, this is a what can you say? Rule, for example. Okay, or you can think that this is a pen. Okay, how many centimeter this pen? It is 12 centimeter, for example, this pen. Okay, I used then 1 out of 3. 1 out of 3 I use it of this pen, of the pen, so means of 12. Okay, it was 12 centimeter, so 1 out of 3 I use it. So how much I use it? So how much 1 out of 3 of 12? Look, finding a fractions of a number. How I can do this? So if I am doing 1 out of 3, then let's cut these equal parts, 3 equal parts. Okay, then how much I used here? If I cut 3, 1, 2, 3, then if it's the all is the 12, then what I have to do? I have to do, of course, division by 3. Make divided. Look, it's divided 3. It is 4. So all pieces, these, each pieces, how many centimeter anymore? It is 4 centimeter. 4 centimeter, 4 centimeter. Because I made it 3. Okay, if I make 3, then I have to make division by 3. So it is 4. 4, 4, 4. So how much I use it? How much was this? Of course, it is the 4. So what did I do? It is 4. How I find then? Look, if they are asking us the fractions, so please make division by denominator, then make multiply by numerator. Okay. For example, if I ask to the 3 out of 12, what can you do? You can do that. 12 division 3, it is 4. This is one pieces. You find anymore. But look, it was 3 totally. 3 totally parts is 12. So 1 is 4. But I need 2. Then it is 8. Okay. What we have to do, you have to look. For example, another question. So 3 over 10 of 3,000. Okay. For example, think that this is the $3,000. So I am spending 3 out of 10. How I can do? Divided 10. How? It's easy. Cancel this. So it is 300. This is the one part. 1 out of 10. So I need 3 baht. So make 3 times 30. Then it is 90. Okay. Good. Bravo. So let's look at the decimals. Okay. Like fastly. How I can do decimals? Okay. Just remember 1, 2, 3, 4. Look, voltings I cut 10 times. Okay, 1, 2, 3, 4, 5, 6, 10. If I am getting the one things, this is the 1 out of 10. Everybody know this. So in same time I can show like a decimal forms that this is the 1.0.12. 0.12. Okay. So for example, if I choose 2 out of 10, then it is 0.2. It's going to like that if I choose, for example. So all ones is 0.1, 0.1, 0.1, 0.1. Okay. So this is the decimal forms anymore. Okay. How I can read these ones? Oh, it's easily. Look, 0.4, for example. Let's remember, here is the decimal part. Okay, this is the decimal point, and here the whole part. Okay, this is the whole part. So how many volts is here? 0 volts. Look, 0 volts. Just some pieces of the volts. How many pieces? For example, if you choose to just one, it's still just one piece. But how many? From 10, of course. Okay. From 10. Because this is the tens. So in same times, here is tens. Okay. Here, remember this. What was that? It is ones, because this is a normal number, but this is the after the numbers. So the place value of here is tens. We are just remembering. Okay. And let's read these ones. How I can read? First, I can read like 0 0.4 or 0. You can tell these to say that this is tens. You can read like 4 tenths. Okay, or other way, you can directly read 4 tenths. Okay, or you can read like 0 whole, okay, and 4 tenths. You can read because it's 4 tenths. If it's 4 tenths, before it I want to show you that how I can show on a number line. Okay, these are the between of the 1, 0 and 1, smaller than 1, because look, 0 walls, no walls. If it's the wall something, it must be bigger than 1, but it's not. And so how I can do then? Let's continue. Look how many pieces. 1 2 3 4 10. 1 2 3 4 5 6 7 8 9 10. 10 pieces this is. Let's show this 0.4. Where is this? All pieces was 0.1. So 1 2 3 4. Here 0.4 and here 10. Okay. So let's come to hundreds. Okay. Hundreds. How we can do this? So just think that again like that, but how many times? 100 times they cut it. Okay, so this one pieces is 1 out of 100. So it is, we are showing like this. Okay, we show this like that. Okay, if it's showing like that, so it means that 1 out of 100, not 1 out of 10. This month means 4 pieces from 10, but this 1 piece is from 100, because just 1 digit here's anymore 2 digits. Okay, so let's look at here. This is, of course, these together decimal parts, decimal point and whole part again. But here this is the ones, so this is tenths, and here hundreds. Don't forget this. Okay, so it's the same things. For example, if I can read this, how I can read this? 0.01 you can read, or you can read 100 you can read. It's going to like that. Okay, look, 1 you told here 1, but here it's hundreds, that's why you are calling like hundreds. But before, for example, 4, not hundreds, tenths, 4 tenths is the same. Okay, and for example, if they are greater than 1, these walls always 0, but this is not 0, it can be the something's different too. Okay, so for example, this 1.0, it is 10 out of 10. What about this 1.20 is like that, so it is means 100 out of 100, isn't it? Same, so it is the always 1. They are the 1. So if there is 1 0 after the point, means that we are talking about the tens. If there are 2 zeros, we are talking about the 100. Okay, hundreds we are talking about right now anymore. So for example, 1 out of 4. What it means? It means that 1 volts and 4 tenths. 1 volts, 4 tenths. Okay, for example, this, how I can read? 3 volts and 21 what? 2 digits, look, not tens, hundreds. 21 hundreds. We are fast, huh? So we must be fast to remember very well. Okay, so let's look at the measurement. Easy one. Okay, so in a few minutes we will finish, then you can learn these all things in a fast way. So units of the length. Okay, length. So what was that? Okay, remember the units: kilometer, meter, centimeter, and millimeter. I hope you understand from my handwriting, huh? I don't write words like that, but I must fast. So 1 kilometer is equal 1000 meters. Okay, so they are writing in same time I am writing too. Okay, let's do like that: kilometer, meter, centimeter, and millimeter. Okay, the short names. So 1 kilometer is 1000 meters. 1 meters it is 100 centimeters, and 1 centimeters is equal 10 millimeters, and 1 meters is equal millimeters. Okay, so let's keep like this. Okay, we will come to for examples. So let's look at the units of mass. These are the measurement. We are trying to find some things, how much that one. So length we are using here. So for mass we are using the ton. It's showing like T. So we are using kilogram. It is showing like kilogram, kg. Then milligram, it's showing milligram. Okay, so 1 ton it's equal 1 kilograms. Don't forget, 1 kilograms equal 1 grams. So 1 grams is equal 1 milligram. Okay, so units of capacity. So easy this is. Just liter showing like L, then milliliter showing small m and L. Okay, so 1 liter, how much? It is what you know, 1000 milliliter. Okay, so you have to know this, what was these are. For example, 1 ton, how many kilograms? 1000 kilograms. 1 kilograms, how many grams? For example, 2000 grams. For example, 2 kilograms, how many grams? 2000, of course, because 2 times you must make multiplication. Okay, so let's look at an example. So 3 kilometers, how many meters? Oh, it's so easy. I know 1 kilometer is equal to 1000 meter. So what about the 3? Huh? What about 3? Then of course it must be 3 times, because 1 time is 1000 meters. So 3 times 3 times 1000, then it is 3000 meters. Okay. For example, 5 kilograms. Okay. How much grams? I know. 1 kilogram it is 1000 gram. Then what about 5 kilograms? Of course, it is the 5 times. So 5000 grams. Okay? As like that. For example, 1 liter and 50 milliliter. How much milliliter? Okay? How much milliliter? Totally. There is the liter, so I have to convert. I have changed to milliliter too. I know 1 liter. It is how much? 1000 milliliter. So plus 50 milliliters. Of course, it is liters. Okay. So we are learned measurement. So let's look at where we have to look right now. Geometry. Okay. Let's look at the geometry and let's finish our lesson after the statistic, of course. So easy as I'm writing already knows. We are remember just, or who doesn't know, of course, also they are learning. So lines, points, it's going to do like that. Let's start it from point. What is the point? Just a point. So what about the line? Of course, it's something like that. If you are saying some points from the on the lines, they are going to the infinity. A, B. Okay. Then how I can show? I can show like AB, line AB. I can read also. Okay. So let's look at the ray. What is the ray? One point, one is stopping, it's like a light. Okay. One point is stopping, but the other points from other side is going to the infinity. So I am showing how, like that. Okay, I can read like ray AB. Okay. So let's come to the line segment. Okay. So it stopped. We are remember just right. They stopped. How I show? Of course, I show like this. So let's look at the parallel lines. Look, 2 lines. One line is here, AB line. So other line also C, D. Look, they are going to the infinity. So they are they never cross with each other. Okay, they never cross. They are going to the infinity and they will never come to each other like that. So always they will go like this. So how I can show? Then a B line is parallel to CD line. This is the symbol. Okay. So let's look at the other ones. Intersecting lines. So what is the intersecting lines? Two lines, they cross in somewhere to each other. Just that. Okay. They are going to the infinity, but in M point, for example, intersection point we call, so they cross somewhere. Look here, they don't close. Okay. And so let's look at the other ones, perpendicular lines. Perpendicular lines. What was this? Just remember, it was two lines, key lines for example, and M lines. They are crossing with an angle, how much? 90 degrees. They are close. How I can show? Key is the perpendicular to M. I am showing like that. Okay. So let's don't stop and let's come to the angles. Angles, and then after the statistic we will finish. Okay. Angles. So just we have to remember that one line is going to like that, so other line is going to this, so they are crossing here. I am calling these is angles. Okay, here is the angles, and these two sides, they are the arms of the angles, or other name is sides we are calling. What about here? This point, it is the vertex, just remember. So how I can show this? Of course, x or y. So just careful that this vertex point must be middle, on the middle. Okay, x or y, or y or x, always this you can show, or like this angle of x or y. Okay, so also you can measure the angles with a protractor. How is that? We are measuring the angles by the protractor. It's something like that. There is a point, so here is the 0, here is the 90, here is the 180. You are putting the here to the vertex, then the line will be on the parallel. This one side must be on the parallel over of the 0, then this showing the somethings like this, so you can call. And so let's look at the types of the angles. Okay, types of the angles. One is acute. So how was it? It was smaller than 90 degrees. And the other one is right. So it is just 90 degrees directly. So other is obtuse. Okay, so this is the greater than 90 degrees, so it is the straight. It is straight directly 180. Okay, these are the angles, types of the angles. Okay, so let's look at the triangles, types of the triangles. Okay, this is the angles. So then types of triangles. Okay, let's remember here. So one is equilateral. Okay, equilateral triangles. So what is the equilateral triangles? All sides are the same. This side, this side, this side, this angle, this angle, this angle, they are the same. Just that. So other ones, isosceles. I'm trying to hear isosceles. Okay, Isosceles triangle. What is that isosceles? Just two sides are the same. Okay. Then these two angles which the sides shows opposite of the sides, they are the same too in same time. So scalene triangle, how was it? So easy. All sides are different, all angles are different. Look, two I made to make the same, that these angles from these sides of these angles, then these sides of these angles, but they are different always. Okay, these are the sides. I am looking to the sides and I can say the types of the classified of the triangles, but in same times I can look at the angles, then I can make classify too. I can write different angles too. How? Right angle, for example. This is right angle, 90 degrees. If inside of the triangles there is the 90 degrees, then it's the right angles, right triangles. Okay. So if I could, how was it? Of course, all angles is smaller than 90 degrees. Okay. So what about obtuse? Haha. One angles is enough. This greater than 90s. Okay. If the angles is greater than 90, it's obtuse. Okay. So let's look at the last subjects of the quadrilaterals. Then it is quadrilaterals. Okay. It is quadrilaterals. Quadrilaterals, what is that? It's something like this. Quadrilaterals, four sides. Remember triangles was three, but this quadrilaterals, it is four sides. Okay, so we can write some, we can look to the size and we can write some types of the quadrilaterals. For example, rectangle. What is that? These are the same both sides, but they are the 90 degrees. We just remember, that's why I am fast. Okay, so let's look at the rhombus. Remember rhombus? What was the rhombus? Of course, look, parallel canals, all them, but all them are the same. Okay, so these angles are same, these angles are the same together. This is the rhombus. Okay, square is look like the rectangle, but all sides are the same for square. Okay, rectangle, just opposite two sides are the same. So trapezoid, what is that? This is the trapezoid. Just important things that they are these upside and bottom side, they are parallel to each other. Okay, this is the trapezoid. And kite, it is like kite. Everybody know, every child. These are the equal, these are the equal. Okay, so these rectangle, the angles are the same. Okay, so it's like that. So let's look at the congruent and similar. congruent and similar. Okay, so what is the similar? Similars are the same, has same shape but different size. What I mean, for example, this one, this can be okay, so other can be like that. Look, shapes are the same but size are not same, so this is the similar. Okay, so what about congruent? Same shape and what was same size. So you can do like that. One shape you can draw, so other shape also though you can draw, but same size. Look, size are the same, so shapes are the same. This is congruent. So similar, different size, just one big or one smaller. So last, for the last really, symmetry, but for geometry is the last. Then we are having statistics. Okay, so symmetry is something like that. For example, think that there is a figure like this. Okay, so I want to make the symmetry of this, but I need a symmetry line here. Okay, I need a symmetry line here. I have to need. Then if I make symmetry line, then I must draw the same shapes here. Look, this is the symmetry. Okay, for example, think this letter. Where? So how this like be? Of course, I have to cut from this side. Then this is the symmetry line. Okay, so look, this side are the same. Look, it's one is coming here, one is coming like that. Okay, this symmetry line. Okay, so we finished this subject. Okay, so let's look at the statistics. Let's look at the statistics. Okay, so statistics is means like collecting and organizing data. This is something like statistics. Okay, for example, do you know, everybody knows survey? You are asking the questions. So you are making a survey and on the class, for example, and it's about like favorite subject. Okay, favorite subject, this is your survey. Then people, your classmates, answered like subjects, for example, for the what? For the maths, then science, then arts. So this is the tally chart right now. I am doing is the tally chart. You are writing the answer of the survey. What you got from survey as answer, you must have a tally chart. So you have to write your answers. You don't have to forget. For example, this is the number also. Okay. For example, you asked one student and one student answered yes, my favorite subject is the maths. Other also said maths, so you have to write like that. So other one say that it's the art, the other one is the said science. Then if always you do, then you don't continue like that. If you done 1 2 3, so with the 5, the last one, you can make like that. You can close to your these your lines, your blocks. Then everything is like a 5. You can block, then you can easily calculate 5. Then another one, for example, they ask, so other, for example, this. How many you answered for maths? It is 6 for 3 and for 2. You can make some comment for this, for example. Which favorite subject, which lesson is the most favorite subject? Of course, maths, for example, you can tell. You can ask or you can do. So, other ones is the mean or average. Okay, mean or average. What is that? It is that you are writing here the sum, then you are writing here the number. Okay, what I mean, for example, in the class, one student has 90 degrees for maths, other students from science, or same students, okay, science, she got or 70. Then from computer she got how much, for example, 50. What is the mean then? It was the sum, so you have to calculate 70 plus 50, the number. How many you calculated? How many number you write? 1 2 3. So you are writing 3 here. Totally 90 plus 70, it's how much? 160. Then plus 50, 210. So it is, as you can see, the division is like 70. So range is writing like that. Maybe you cannot understand from the right. Okay, it's like range. So what is the range? Range is you are looking to the difference of the greatest number and smallest number from your answer. What is the greatest one? 90. What is the smallest one? It is 50. Then how much the range? It is 40. Okay. For example, reading book. Another question. Okay. Students is reading in a first week in this corona days. In the first week, for example, he read 3. Second weeks, he read 5 books. Third, he read 10. Then fourth, it is 1. Then last week, he read 6 ones. So let's look at the mean or average. How I can do? I have to make calculate. Okay, 3 plus 5 plus 10 plus 1 plus 6. Then how many I added? I used 1 2 3 4 5. So what is that? Of course it is 25. 5. Then it is mean is 5. So what about the range? So let's look at here. What is the maximum? Is 10. Smallest is 1. Then it is 9. So range is the 9 too. So our lesson finished here. So you had right now the reviews of the maths from multiplication, multiplying by 2-digit numbers to until the statistics. So right now, if you know all these subjects, it means that you know all kind of these things. So this was the grade 4 maths. Then see you.